Good morning and Jai Swaminarayan. Welcome in lecture number 3. In last two lecture, we complete anti-malarial drugs. In this class, we synthesize our according to our syllabus 3 anti-malarial drugs. Now, next group is antipyretic and analgesic drugs. In this group, first of all, I give introduction and then synthesis. Antipyretic and analgesic drugs, both classes are studied together. So, in this class, we have 7 drugs: antipyrine, aminopyrine, phenacetin, paracetamol, aspirin, Salol, and heptazone. In this lecture, first 3 drugs, antipyrine, aminopyrine, and phenacetin, we synthesize in this lecture, and remaining 4, paracetamol, aspirin, Salol, and heptazone are in next lecture. So, first of all, we start with introduction. Antipyretic and analgesic drugs. An antipyretic is a drug which is responsible for lowering the temperature of a feverish organism to normal, but has no effect on normal temperature states. In our body, if temperature is rise, then we use antipyretic drugs. On the other hand, an analgesic is a drug which relieves pain without the loss of consciousness. In the earlier days, the antipyretic compounds studied and synthesized were also found to have analgesic properties. Therefore, these two types of drugs are studied together. However, some compounds have only antipyretic properties without any analgesic actions. Now we start first synthesis. Antipyrine. Antipyrine is synthesized by two starting materials. One is acetoacetic ester and second is phenylhydrazine. On condensation, acetoacetic acid gives oxygen and phenylhydrazine gives H2 hydrogen. I describe oxygen from here. Oxygen from here, C double bond O, and H2 from here, and remove H2O minus H2O. Then we get condensing material for phenyl hydrazonone pentanoic acid ethyl ester. This 4-phenyl hydrazonopentanoic acid ethyl ester is cycling by removal of ethanol gives 5-methyl 2-phenyl 2,4 dihydropyrazole 3-on. 5-methyl 2-phenyl 2,4 dihydropyrazole 3-on. Numbering starting from here: 1, 2, 3, 4 and 5. So 5-methyl 2-phenyl 2,4 dihydropyrazole 3-on. Now this 5-methyl 2-phenyl 2,4 dihydropyrazole 3-on is treated with alkaline solution of methyl iodide, alcoholic solution of methyl iodide CH3I, and finally methyl iodide. This methyl CH3 from methyl iodide is reacted with this nitrogen, and finally we get our last product, antipyrine. Chemically or IUPAC name of antipyrine is 2,3-dimethyl 1-phenyl pyrazole 5-on. 2,3-dimethyl 1-phenyl pyrazole 5-on. Now, uses or application of antipyrine. It is administered orally to reduce pain and fever in neuralgia and migraine and other headaches. It reduces pain in muscles, pain in joints, and inflammation of nerves. However, it is less effective than salicylates and more toxic. Our second component is aminopyrine. We synthesize aminopyrine from antipyrine. We synthesize antipyrine in above synthesis. So, this is the structure of antipyrine. Now, antipyrine is treated with NaNO2 plus HCl at 0 to 5 degrees Celsius. This reaction is known as diazotization. Here, note that the temperature 0 to 5 degrees Celsius must be required. If temperature is higher, above 5 degrees Celsius, then the diazotization is not completed and we get loss of yield. So here temperature 0 to 5 degree must. From sodium nitrate NaNO2 gives nitroso component NO. So diazotization of antipyrine give nitroso antipyrine. And after diazotization, the product nitroso antipyrine is reacted with zinc plus HCl. This reaction is known as reduction. Acid metal reduction. On acid metal reduction, we get aminopyrine. Please note that in reaction, our nitroso group NO is converted into NH2. So it is known as reduction. After reduction, methylation is carried out, and it is carried out in alkaline alcoholic solution of methyl iodide CH3I, and finally we get our product aminopyrine. Aminopyrine. Uses or application of aminopyrine. It is nearly 3 times more powerful than antipyrine. First we synthesize antipyrine and next it is aminopyrine. So it is 3 times more powerful than antipyrine. Although it is a very useful drug for treatment of mild pain. Its sale has been prohibited in many countries because of it has been found to be cause heart disease. Now, last synthesis, phenacetin. We synthesize phenacetin from phenol. On phenol, we carried out nitration unit process, nitrating mixture of nitric acid and sulfuric acid treated at low temperature on phenol gives para-nitrophenol or 4-nitrophenol. Now, para-nitrophenol is treated with bromoethane C2H5Br. C2H5Br. On this reaction, we get 1-ethoxy-4-nitrobenzene. From bromoethane, C2H5 group is introduced, replaced by hydrogen. So we get 1-ethoxy 4-nitrobenzene. Now the metal acid reduction of 1-ethoxy 4-nitrobenzene is converted into 4-ethoxy phenylamine. Here note that NO2 group is converted into NH2, so it is metal acid reduction. 4-ethoxy phenylamine is treated with acetic anhydride. Acetylation unit process takes place here, and in this structure the NH2 is converted into NHCOCH3 and removal of acetic acid. So it is known as acetylation or acylation. It is must be carried out in presence of acetic anhydride. So finally, last we get our product phenacetin. And last, uses of phenacetin. It is an effective drug for treatment of mild to moderate pain due to neuralgias. However, a significant percentage of patients have developed blood dichrisis on repeated use of phenacetin. So, prolonged use it has several side effects. In this lecture, we study our three component antipyrine, aminopyrine and phenacetin. Next lecture, we studied remaining four compound of antipyretic and analgesic drugs. In this situation, please take safety precaution for our health. Use masks properly and all time. Maintain social distancing. Wash hands regularly with soap or hand wash. Use sanitizer frequently. Drink hot water all the time. Thank you.